Alright guys, so on this is what we're going to be doing. I'm doing this video first off, show you this key. I want you to work through these and see how these problems are solved. Please understand something that you're going to first need is a handy dandy periodic table. I have one here with me, and a calculator. Now I'm using one like we're used to inside the classroom, but you may not have that, and I'm going to darken it in so you can see it better. Now in this, please understand the importance of not only first knowing how to get these calculations right, but secondly knowing how to get these things in this calculator properly and correctly, okay? So we're going to do a couple things. Now this video's going to go quick, so I don't want you to get so stuck up on how fast I'm going. I want you to be ready and prepared. Okay, that's why I'm going so quick, so you can have this video and it doesn't take forever to get through it. If I work a problem and you don't understand what I've done or how I've got it, just simply go back. This is a video. Run the video back. That's what you have. Message me on Remind if you have any questions. So in this, we're going to work as we've been working. So, use some different colored pens here. So first we are going to look at number 1. What is the mass of a sample of carbon that has 0.3548 moles of carbon in it? In this, mark your starting point. The dead giveaway is the number. My number, the number I give you and those units are telling you the starting point. So in this, I'm going to start right here. Now mark my end point. Where am I wanting to go? What is the mass? So the mass of the sample. And whenever I'm asking about mass, what units am I looking for? Hopefully you can say at this point grams. So in this, you should be able to formulate a plan. Your plan should be something like this. It shouldn't be something too complex or hard besides just saying, I'm starting at moles, and I'm going to grams, which is mass. So I'm going to mass. The units there will be grams. So now you just set this thing up and you start it up how you always have. First thing you do is you take the number. So 0.3548. Write the units with it. Moles of carbon. So I'm just going to put a C, it's abbreviation for carbon, and we set it over 1. Do not put moles with that number. We're just setting 1 over there. Don't get in the habit of just putting 1 and then moles. Understand, you're putting what you first start with and then putting it over 1. You're making a fraction here. That's all we've done. There's nothing else. Nothing else has changed here. We're just making a fraction of it. So in this, we're going to do some operations. So you should know by this point that you are in need of something. Hopefully you understand you are in need of a conversion factor. Now in this case, we're already in moles. So it doesn't matter where we're going, it's a one step. Because I started with moles, remember you're always either going to be going to moles, from moles, or through moles. This is why we call them mole conversions and mole calculations. So we're going to need a conversion factor. I'm going to set this up right here. And in this case, if you want to use the mole map, use the mole map. But this is how I like to work it. Whenever I look at them and say, I'm looking for what am I looking for? I'm looking for grams. So grams is going to go on top here. So grams of carbon. And I need to cancel out moles of carbon. Now in this case, in the conversion factor, the number 1 goes here because he is number 1. He is the centerpiece. Mole is the centerpiece of this whole thing. Then from here, carbon. But where does that number come from? And this is where I have to stress. I can't stress this enough. This is one of those simplistic problems that's going to be a one-stop and shop. You're looking at carbon. It's an element. Periodic table. On your periodic table are all these values. In these, you're going to look on here. So if I can get the focus. So on here, you have these elements. Now, there's two different pieces of information here. What I'm going to highlight in orange is this 6. And I know a lot of you had this question in class behind what is this Z equals here. What is that? That is literally the atomic number. I'm giving you the atomic number because you don't know these elements yet. So whenever you're on your quiz, I give you the atomic number. That Z equals is the atomic number so you can find that element. I'm looking for you to find it and make it faster for you. Now the piece of information that we need to fill in is the average atomic mass of that element. So we need this right here at 12.011. Now whenever you have that piece of information, I'm not going to do that for everyone. I'm not going to break it down that easy. You're ready to plug in here. So 12.011 grams. So moles cancel. And remember, that number always follows grams. Okay, you're going to see throughout this whole paper. So in this, I got moles canceled. I'm left with grams. I'm set. I can literally find my answer now. So grab your calculator, and in this, work it out. So in this, I have 0.3548, and since these are on the same side, I'm multiplying. They're both in the numerator, so we will multiply, and it gives me 4.2615, and that's grams of carbon. And there's the answer. So 4.215 grams of carbon, and I'm hoping you can see that on the calculator there, but that's what it gives me. Okay? Now in this, that is more of a simplistic problem, just like this one down here. But there's a little trick in the second one. So let's look at number 2. Okay, speeding up a little bit. How many moles are in 12.56 times 10 to the 5th kilogram sample of phosphorus? Remember what that Z is just your atomic number. So on there, we can find our average atomic mass or be able to calculate our molecular mass if need be. So in this case, I'm marking my starting point, my numbers that it give away. I have kilograms. And at this point, I want to stress that. That's the trick. Kilograms. That's a problem. Must go grams. We have to convert that to grams before we can even use anything with it. I noted that the day we started on these things. My endpoint, how many moles? So moles of phosphorus. So in this, the first thing you need to do, if you need to set this up, please set this up. But 12.56 times 10 to the 5th kilograms equals how many grams? Write the number down. Times 10 to the something another. We got to find out what something another is. So let's do a prefix conversion here. So we have kilo. What is kilo? 3 minus base unit. So 0 equals 3. There's no cubes or squared on our units, so it's just straight up. And now we add what we originally started with, which gives me 8. Now I have a new number. Now let's start with this conversion. So 12.56 times 10 to the 8 grams of phosphorus, which is atomic number 15 on the periodic table. And now we're going to set up our conversion factor. So in this, hopefully at this point you've set up a plan. Your plan should be going from mass and going to go to moles. Hopefully you got that. Okay? So now let's set up our conversion factor on this. Okay? So I'm going from, I got grams. Grams have to cancel because they're there in the top. Grams have to cancel, so it goes in the bottom. I want moles, so moles will go in my top. What number goes with moles? 1. So technically mole, but you know I ain't an English person, so. Grams, where does that number for grams come from? Hopefully you're saying to yourself periodic table. Pull your periodic table over and look at it. Remember what number you're looking for. You're not looking for that 15 up there. Remember what we're looking at is this number right here, that 30, can't see it, let me focus it, at 30.974. Okay, this is the number we're looking for. The average atomic mass. So in this case, that number we just found goes right here, which was 30.974. Grams of phosphorus cancel. Lisa was moles of phosphorus, which is what we're looking for. So type this in your calculator. And I know a lot of y'all are going to get worried about this whenever you're typing it in your calculator. Please don't have a heart attack. Use your parentheses first off. They are your friend. 12.56, second comma, which gives me the E. Make sure and just put the E. Do not do that whole E times 10 junk. You're going to get everything wrong when you do that. Just leave E. E stands for times 10. I can't stress it enough. 8. I just typed my exponent in there in parentheses. Now in this case, these are on opposite sides. Numerator, denominator. It's in the denominator, which means I will divide. 30.974. Yes, you can get a number that big. Do not be scared about the number. So 4055013.83. I left no room whatsoever, and these are moles of phosphorus. And there's your answer to number 2. Okay? Slide over, make sure you can see that. So 40,550,138.83 moles of phosphorus. Alright? Pray you guys are catching on with this. Now this second part here, this is, number 3 is going to kick it up a little bit of a notch, okay? In this case, what is the mass of a sample of C2H6 that has 24.6 times 10 to the 24 molecules of C2H6? Mark your end point. We're looking for mass. Mark your starting point. We're dealing with molecules. Now, I want to stress this part to you right here. I know all of us have been finding just using those values off that periodic table. It's going to change because you no longer have an element. This is a molecule. That C2H6 there is a molecule. That is no longer an element. So everything's changed a little bit now. You're going to have to end up calculating molecular mass, which I'll show you in a second. So in this, first thing we're going to do, formulate a plan. Let's formulate that plan. I'm going for molecules. And I'm going to go to mass. Now in this, I want to stress something. Do you see moles anywhere in your problem? Hopefully you can answer no. So in this, you should be stressing the importance of right here, this midway. Guess what you're going to have to do? You're going to have to get to moles. That's why we call these mole conversions. Alright? So we're going to start with the number that we start with, okay? So we're going to take the number that we're starting with, in this case, which is 24.6 times 10 to the 24 molecules of C2H6. We set it over 1. You should see a pattern here. We keep setting this over 1. Nothing's changing here. We're still setting it over 1. The only thing that's changed is where we're coming from the mole map or where we're trying to get to. So in this, we're going to need a conversion factor. And like I said, and I can't stress this enough, we first have to get to moles. So in order to do this, this is the simple conversion. I need to get to moles, so moles are going to have to get on top. Number one goes with moles, and then molecules need to cancel. Molecules is C2H6. I know you can barely see that, but I'm trying to save some room. Now the number that goes down here with molecules is Avogadro's number. I can't stress to you enough, you better memorize that. So 6.022 times 10 to the 23rd. Now in this, you're absolutely right in the thought process that molecules of C2H6 cancel out. I'll just mark through it again because it didn't really mark very well. Now in this, I'm not finished. I'm in moles, but I asked for mass. You have to get me to mass. So in this, take it all the way to where we're trying to find. Set up your last conversion factor. I'm trying to find mass, which is grams, so grams of C2H6 go on top, and 1 mole of C2H6 goes on the bottom. And just like before in class, what's going to go in that blank is not just the information off your periodic table. You're going to use this information, but that's not the dead set thing. You're going to use pieces of information from that. This is where that information will come in handy. You have to calculate the molecular mass for this blank because this is C2H6. That's a molecule. So in that, you're going to be looking. Write down the elements you have. I have carbon and I have hydrogen. How many carbons do I have? There's a 2 there, which means there's 2 carbons. And there's a 6 there with hydrogen, which means there's 6 hydrogens. You're going to multiply those numbers with that element's average atomic mass. So what I'm saying is for carbon, it's 12.011 gram per mole, which should look familiar to you. That's just off the periodic table. We even use it up here on number 1. It's information straight from the periodic table. And then hydrogen is 1.008 grams per mole. Then you're going to find that answer for those two. So all you're going to do is on your calculator, you're going to do 2 times 12.011 to give you 24.022, and 6 times 1.008, which gives you 6.048. You're going to add these two together. Those are grams per mole. I ain't writing it just to try and save time. Add these two together to give you 30.07 grams per mole. Notice, these numbers always follow grams, not the mole. So it follows here grams, so it would be 30.07, which we calculated. Okay, I just wrote it right here, 30.07. Now in this, it's time to do the calculation. So try and set this to where you all can see it. So in this, first thing I got to write, 24, oh, messed up, I need to use my parentheses. 24.6 second E, and that's to the 24th in parentheses. And then I have right here, Avogadro's numbers in the denominator of this, which means I will divide, denominator divide, parentheses, 6.022 second E 23, in parentheses. Now you're looking in terms of what we started with. Is this number in the numerator or denominator? It's in the numerator, which means we multiply. So times 30.07 in parentheses, and we get an answer be 1,228.3660, and that is grams of C2H6. Okay? Hopefully you can see on the calculator the reason that rounded up to that is because that 5 and a 9, but there's a 9 behind that 9, which means the 9 rounds up to give me the 3660 there, okay? Hopefully you're doing good at this point. I believe you are. Number 4, okay? Rolling it up a little bit more. How many formula units are in a 12.5 gram sample of Na2O? That is sodium oxide. Okay, I give you the information here. All these are, just like before, all these are the atomic numbers. So you can find them off your periodic table really quick if you need them. So in this case, mark your start point. Start point's right here. I give you the number in grams. There's my starting point. End point's right here. I'm looking for formula units. Now this is where I gave you all those units at the end. Molecules, particles, formula units. All those. Formula units go at the end. Okay? So, here's what we're looking at doing. Set this thing up just like we have before. Figure out what we're going to start with. We're going to start with mass, formulate my plan, and I'm going to go to formula units. This should look very familiar. Because look, do you see moles anywhere in this? No. But guess what? Moles is there. Moles is right here. You have to go through moles. You're either going to moles, from moles, or through moles. So we have to go through moles. So let's start this thing off just like we have before. So 12.5 grams, and this is Na2O all over 1. Continuing on with this, we're going to set up our first conversion factor, okay? Your first conversion factor. I need moles. So mole of Na2O goes on top. Number 1 goes with it, and grams of Na2O goes on the bottom. You should be able to explain to me now at this point the reason grams is going on the bottom is so that these grams would cancel. You also should be able to look at me and explain to me where we're going to find the number for that blank. We're going to go on the periodic table. So we're going to go on the periodic table. We're going to use this information. Z equals 11 for sodium. Right there's sodium. And then Z equals 8, which is oxygen. There's oxygen right there. Now I'm going to use those average atomic masses, okay? That's all I'm going to do. I'm not going to work that whole thing out. I'm just going to punch in the calculator really fast so we can work through this. So in this, to find what's going to go in that blank, this is literally what I'm doing. I'm putting parentheses in there. I have 2 sodiums. So 2 times sodium's average atomic mass is 22.990 in parentheses plus 15.999, which is oxygen's average atomic mass. I hit enter to give me that number. That number is what's going to be the key here. 61.979. I'm doing horrible at leaving me room. All that is 61.979. Okay? From here, are we done? No, you are not done. Grams of Na2O cancel. But am I asking for moles or formula units? Formula units is the key, so we got to keep going. We need to get to formula units, but this is the one that is simple. This is why I love this. This is the one that I pray you do not mess up on. Okay, what am I looking to cancel? Moles. So 1 mole goes on the bottom. What goes on the top? Formula units. Of Na2O. And in this, what number goes there is Avogadro's number, 6.022 times 10 to the 23rd. Now in this, you're going to find this. Definitely can't do that in pink and purple, because it ain't going to stick out real well. So that'll be equal, those punches on a calculator. Alright, so in this, I'm going to start off 12.5. Okay, I got 12.5 on the top. This number's in the bottom, which means I need to divide by 61.979 in parentheses. And then I got Avogadro's number in the top. Numerator means multiply, 6.022 e to the 23, and that equals. Now I want to stress something here. As you see in this calculator, see this big long number here. Take 4 places past the decimal. 1.214.5. You see that E? That stands for times 10. I can't stress it enough. Times 10. My pen's not writing really well, but times 10. And that 23 is the exponent. 23, and that is 4 million units. I also can't stress enough how important your units are. So 4 million units of Na2O. I'm running out of room. So there's the answer for that one. Now 5 is one of my personal favorites. I'm going to give 5. It's so simple. Are you ready for this? Whenever you're looking at this, what is the volume of a 78.56 kilogram sample of H2SO4? I'm going to openly admit to you, right here, right now, I put this in here to try to get you to catch that as a trick instead of focusing on the rest that actually is the trick. So that trick not mattering right now, and there's a reason as to why. What is the volume of 78.56 kilogram sample of H2SO4 sulfuric acid within a room at 298.36 Kelvin and 4.58 atmosphere of temperature and pressure? Right there's your key, ladies and gentlemen. This should just raise a red flag to you right now. These two informations right here, because I gave you a temperature and I gave you a pressure. This is not standard temperature and pressure. That's why this trick is here, to try and make you think that's the trick and for you to miss this. Because here's your answer to 5. Can't solve. Not at STP. Because I gave you values for temperature and pressure, I'm literally selling it to you. I'm telling you straight up, you cannot solve this. Do not try and solve this. You cannot solve this. That is a quick question for you. If I give you values for temperature and pressure, it's not at standard temperature and pressure, which means you cannot solve it. Okay? So there's the front half of that. I want to move on to the second half. Now, those weren't too bad. The second half gets pretty rough. That's the wrong one. Sorry, hold on. What do I do with it? Here we go. Here's what we're looking at. So mole conversion practice, and we're just continuing this. So what is the volume of 78.56 kilograms of H2SO4 within a room at standard temperature and pressure? In this, do what you've always done. Mark your starting point. Here's my starting point. I have a mass. That's what kilograms is, a unit of mass. Volume. We haven't done one of these yet. Not in this video, but we're going to do it now. It's Good practice. In this, please notice something. Kilograms have to go to grams. So I'm going to convert that when I first start out. Formulate a plan. Here's the plan. We're going to go from mass to volume, which is what we're looking to do. I'm at standard temperature and pressure, which means I can. Please remember what goes in there, right here in that center. You have to go through mole. We have to get the moles first. So in this, work this problem out. I'm going to go on and jump here. Don't freak out on me. I just converted that to grams. I didn't write the whole problem thing out like you guys are used to seeing. Okay, so all that is 78.56 times 10 to the 3 grams. I get that because kilo is 3 minus 0 because grams is the base unit. Set it over 1. From here, set up conversion factor. I'm trying to get moles. Moles goes on the top. H2SO4. Grams of H2SO4 goes on the bottom. I want to stress this out to you. I know you haven't did one of these yet that has 3 elements in it. You do the same thing. You write it down. Nothing has changed in that fact. You just write down hydrogen, sulfur, and oxygen. How many hydrogens I got? 2. How many sulfur? 1. How many oxygens? 4. Multiply them by the average atomic mass off of the periodic table. Hydrogen is 1.008, that's grams per mole. Sulfur is 32.066, double check, yep, 32.066 grams per mole. And oxygen is 15.999 grams per mole. Once you do that, you find out what these are equal to. Get that, get that, get that. You add all those together. So you add them. That's all I'm going to do. I'm just going to add them. I'm throwing it all in my calculator all together at one time because I don't feel like writing it all out. So I'm doing 2 times 1.008 plus 32.006 plus 4 times 15.999, and I hit enter, and it gives me the molecular mass as 98.018, and that's grams per mole. Like I said before, remember this number follows grams. Make sure it's following grams. So let's go 98.018 grams of H2SO4. Add H2SO4 here. Cancel. I'm in moles. Am I in volume yet? No! We still have to go to volume. Another conversion factor. Remember from this, this is the second one that is just there for you. We're setting it up easy for you. Okay? Moles need to cancel. Moles go on the bottom. What goes on the top is a volume. What volume did we learn was the liters of H2SO4. What number goes there is at 22.4. Once you do that, you can find your answer. Put it in orange, just because I think orange looks cool. So, setting it up, as probably want to see this, sorry. Parentheses 78.56 to the third, and this is in the bottom, so I divide 98.018, that's in the top, so multiply, times 22.4, you should get 17,953.2739. I know it looks like I skipped that 8, but I didn't. 8 rounds up to 9. And that is liters of H2SO4. box that in there so you can see your final answer. Hopefully you're picking up on this. Hopefully you're catching on. Okay, I'm really going to start rolling through these now. Okay, what is the volume? My endpoint volume of a gas of 9.56 times 10 to the 25th molecules sample of H2S at standard temperature and pressure. Standard temperature and pressure, I can solve the problem. In this, formulating my plan, I'm just going to go for molecules and go to volume. So 9.56 times 10 to the 25th molecules of H2S. Set that over 1. I got to get from molecules to volume. Before I can do that, though, I have to get to moles. So 1 mole H2S. I need molecules to cancel. 6.022 times 10 to the 23 molecules. If you don't know where this is coming from, I've worked through enough of these. You should be getting a feel for this. If you still are not getting where I'm getting these values from and pulling it this fast, you need to go back and watch the video again. Molecules H2S cancel, but I'm not in volume yet, so I'm not done. Look at it again, set it up. I need moles to cancel. I need to get to volume, so 22.4 liters, all right, of H2S. Now we'll set all this in the calculator. Be 9.56, second E, 25, right? Yep. Divided by 6.022, second E, 23, times 22.4 equals 3,556.02739 liters of H2S. Oops. Must have been my box too short. Okay, there's the answer for that one. Number 8. Rolling right on. How many molecules of SO2 is found in a sample that has 789.245 centimeters cubed of SO2 at standard temperature and pressure? I'm at standard temperature and pressure. I'm being asked to go from a volume. Centimeters cubed is a volume. So in this, I'm fine. I can do the calculation, standard temperature and pressure. In this, remember, centimeters cubed is just milliliters. So I need to convert that over, and I will start with 789.245 milliliters. I need that into liters, which is 789.245 times 10. Milli starts, -3 minus liters is base, so 0 equals -3, so this is -3. Now set your problem up as you always have and just work it through like that. That was the trick, but remember, centimeters cubed, there's a trick inside the trick. So 789.245 times 10 to the -3 liters SO2. I need to get rid of that. I need moles first. And I need to get rid of it, so 22.4 liters. I gotta get rid of the liters. Liters cancel. I'm left with mole right now, but that's not what I'm asked for. I'm asked for molecules. So I need to get molecules, so 6.022 times 10 to 23rd molecules. Man, it's looking really sloppy. SO2, I'm running out of room. And 1 mole of SO2. Moles of SO2 cancel, leaves me with molecules. So in this I can get my answer. So I need 789.245 to the -3rd divided by 22.4 times, because it's in the top, 6.022 second, 3 gives me 2.1218 times 10 to the 22nd. And these are molecules of SO2. Okay? Ooh, got 3 minutes. I gotta solve this. Alright, I'm solving these really quick, so if you think I've made an error, just ask me. Message me and remind about it. Last but not least, ladies and gentlemen, what is the mass of nitrate, that's NO3 negative, found in a sample that has 12.78 times 10 to the 8 microliters? So, starting point, I'm in a volume. End point, mass. At standard temperature and pressure, which means I can solve it. I'm at standard temperature and pressure. So from here, I need to do this conversion. To do this conversion, I get 7.8 times 10. I'm just going to write out here to the side this conversion for you, okay? So I got micro is -6, minus, I'm going to liters, which will be 0, which equals -6, and you add what you originally start with, which is 8, give me 2. I have a choice here. I'm going to put liters of nitrate. There, okay? But this is the thing. If I just wanted to do this, and just to show it to you on the calculator, 12.78 to the second is 1,278. So I'm just going to set this thing 1,278 liters of nitrate. Now in this, let's start working these calculations out. It's pretty difficult ones here. So 1,278 liters of nitrate, set it over 1. I need to get rid of liters of nitrate. I'm trying to get to mass. Before you can get to mass, you have to first get to moles. So we are looking at getting rid of getting moles. So 1 mole of nitrate. And we're looking to get rid of liters. So 22.4 liters of nitrate. Liters of nitrate cancel, leaves me with moles. But I'm looking for mass, so I'm not done. I still have to keep going here. Another conversion factor. Looking for mass, so that'll be grams of nitrate. And I'm canceling moles, so 1 mole of nitrate. Moles of nitrate will cancel. What goes in the blank there? You're right, ladies and gentlemen. Hopefully you're catching on to the fact that I've given you these atomic numbers. And you're looking on your periodic table. And you're looking at these and you're looking in the right spots and seeing we're going to have to use 14.007 and 15.9999 for our nitrogen.
The following students attended the GM: Tommy Milan, Christy Martin, Tyler Fortner.
So hopefully you're seeing that in this point. And what you're going to do in this is you're going to remember you're just dealing with nitrate. Okay, so you see where I'm getting these numbers from. You don't. Hopefully you're following me there. So in this case, you're going to take nitrogen and oxygen. You have 1 nitrogen, 3 oxygens. It's 1 times 14.007 and 3 times 15.999. 7 grams per mole, and 3 times 15.999 gives you 47.997 grams per mole. And you will add these two together Okay? Understand, nitrogen, there's not a 1 there, but since it's not 1 there, you understand there's a 1. It's like in math class when there's X. You understand there's a 1 in front of it. So 47.997, and I'm just going to add 14.007 to that to give me 62.004 grams per mole. And so in this, that number goes on there, right there at 62.004 grams of nitrate. In this, you're going to punch all that in the calculator. So I have 1,278, put parentheses, 1,278, parentheses are our friends. Denominator, so I divide by 22.4. Numerator, so I multiply 62.004. So we get 3,537.5496 grams of nitrate. Okay? Now listen, these are not simple problems on this back, okay? They're a little bit more complex. Make sure you can work through these with me. Don't think that you're just going to watch me do these. Actually do these calculations at home. Work it out. See if you get what I get. If not, you need to come see me. Second period, you can come see me in the morning. Second period, you can also come see me during first period and fifth period. You have the luxury of seeing me first period in the morning at 7:05, or you can even come see me during lunch at second lunch. So you guys have a wonderful day. I will be releasing the percent error practice sheet as well.